We're continuing a review of Chapter 11, and we're in Part B of this review. And we're going to be talking about infinity. Well, infinity is a number so large that we don't know it. So, in a positive infinity, in a negative, of course, it's the smallest. So that means, I think a Google has 18 zeros. I could be wrong on that. I could be wrong. Well, anyway, this isn't even the largest number because there's one even larger. So infinity means very large, positive or negative in the case. When we draw a number line, have 0 as our start, and then if we head this way, we reach infinity in the positive, and this side is negative, so that you recall that. So what are we going to work with on this? Well, we understand that 1 over infinity is approaching 0, but never getting there. So it's a limit. So we take a limit on that, and we say, oh, well, it's 0. Well, what if we had 1 over infinity squared? Well, that is beyond comprehension how big that number is. So we would have, again, approaching 0. Okay. And in the negative, it's also the same. It's always approaching that 0. And since we're talking graphs, we're talking this guy right here, or this guy right here, or this guy right here for negative infinity, and positive and negative infinity. So you can see that this type of concept and getting approaching 0 is able to give us an attitude of where this function is going. So let's talk about the first one. And we notice this is a polynomial. Therefore, its domain is negative infinity to infinity. And we want the limit as x approaches, and I'm pretty sure that's just plain infinity, of x squared plus 4x minus 3. So we're going to just take that limit, and we're going to have infinity squared, which is tremendously large, plus 4 times infinity minus 3. So therefore the limit is infinite in nature. The limit, as we approach infinity, of a polynomial is infinity itself. All right. Well, we have a rational expression. And if you recall algebra, if the degree of numerator is degree denominator, then you have a horizontal asymptote at the coefficients of that Okay, I can write this correctly. Sorry. So if they're the same, if n equals m, then y equals ab is a horizontal asymptote. That means as you go in the end zone, it approaches but never gets there. Well, here we have this. All right, but we want infinity. Well, we can't divide infinity by infinity. That's ridiculous. So what we're going to do is divide by x to the m. That's the largest degree of the denominator. Denominator, because we know that, as we talked about it up here, it approaches zero, right? So we want that condition. All right. So in this case, we're dividing through numerator and denominator for equality. X squared. All right. So we're taking the limit as x approaches infinity, and we're going to take the 2x squared and divide by x squared minus x divided by x squared minus 3 divided by x squared. All right, over. And then we're going to have the bottom 6x squared divided by x squared minus x divided by x squared minus 1 over x squared. All right, so we're going to simplify. And that'll give us a 2 minus 1 over x minus 3 over x squared all over 6 minus 1 over x minus 1 over x squared. All right, now we're going to apply it. So this would be 2 minus 1 over infinity minus 3 over infinity squared over 6 minus 1 over infinity minus 1 over infinity squared. All right, so we know these guys are what? Yeah, buddy, 0. So what am I left with? I'm left with 2 over 6, which is 1/3. Therefore, and we know that's going to be the horizontal asymptote as well. But for us, it's a limit. It's approaching so close that it can almost feel it. That x 0, y equals 0 as a to the 1/3. I'm sorry. So the answer is the limit as x approaches infinity for 2x squared minus x minus 3 over 6x squared minus x minus 1 is 1/3. So, supposing we're doubting Thomas's, well, we can go to y equals. And remember, when we're doing this, it's parentheses for numerator and parentheses for denominator. Hit the divide. Okay, now I'm going to do the denominator. My parentheses, I'm going to go zoom 6. I don't know what I have. And sure enough, we can see, we can even add the horizontal asymptote, which is y equals 1 divided by 3. And we can graph it, and you can see that it approaches it. Look how close it is as we go to the infinities. This is positive infinity here. All righty. So we got that. And you can always use your calculator to understand. Well, here, when in the algebra, have x to the n over x to the m, and that means the degree, the highest degree. Well, I'm going to have a 2x squared is the highest degree of the numerator, and 3x to the 4. Well, what we have here is n is less than m. So the horizontal asymptote is at y equals 0. So we're figuring that out. But we understand from algebra that the limit is going to be 0 as y continues to the extremity. And this one is positive as well. And of course, we're going to divide by x to the 4th, because that is the highest degree in denominator. So we're going to set it up. And we're going to have the 2x squared over x to the 4th minus 1 over x to the 4th. And we get a 3x to the 4th divided by x to the 4th plus 4 over x. Now we're going to simplify that material. So we're going to have the limit as x approaches infinity of, and now this will reduce to 2 over x squared minus 1 over x to the 4th. And on the bottom, I'm going to end up with a 3 plus a 4 over x to the 4th. Okay, now I'm going to take the limit. All right, so that means I'm going to have 2 over infinity squared minus 1 over infinity to the 4th over, and now I'll have a 3 plus 4 over infinity to the 4th. Well, what happened here, guys? Yeah, this is 0. Bam, this is 0. So I'm going to have a 0 over 3, which means 0. So the limit as x approaches infinity of 2x squared minus 1 over 3x to the 4 minus plus 4, sorry about that, is 0. And we said it from that algebra component. All right. But it is a limit. We're talking, where is this function leading towards? At infinity. It'll get very close. So now we're at 11.3, which was the rate of change. And this is knowledge about slope types. All right. Because they're talking rate of change. And you can think about a car driving. Your speed is a rate of change. And we know that rate is distance divided by time. All right. So if we can put that in our head, we understand that's also slope. And slope is the first one we're looking at. From one point to another, a direct line, slope. It's a direct line. From one point to another point. To measure change. All right, so let's look at this average rate of change. Think of it as speed, all right? The average rate of change of f of x with respect to x for function f, and x changes from a to b, from some start point on the function to another point on the function. This is the a point and this is the b point. So we're finding the average. Of course, it's not good because we've got a big old drop in inclusion, but this is called a secant line if we're looking at a graph for 2 points rather than instantaneous rate of change. So this is nothing more than a slope formula. So this is y's of 2 minus y's of 1 over x sub 2 minus x of 1, because these are ordered pairs. And we understand that from all the algebra we have taken. So let me make some room. All right, so we know that the x value is b, and then the y value is f of b, and then we're saying that the next point, the first point, the initial is a and f of a. So what we're talking about is x of 2 and y's of 2, x of 1, y sub 1. So that's what it is, because we understand the functional notation. That means the outcome. It's asking the outcome at that value. Now, the other one is the more important, and this is the instantaneous rate of change. Now, in college algebra, or algebra 2, we know it as difference quotient. Calculus, know it as instantaneous rate of change. What this gives us is a function, general form of a rate of the function movement at one point. So if we looked at this one, I says, well, how fast are we going here? Well, the instantaneous rate is that line that pierces that point and determines that rate of change there. All right. So now you see the difference between the secant line and the instantaneous rate. It is a process, and it takes a limit as the change of x, which we make it very small for a function of a. Well, I don't like a, I just like x. So I'm going to write it in algebra form, so it'll be a recall for you. X plus h minus f of x, the start one, divided by h. And h is the change. And of course, we're approaching 0. So we have this problem here. All right. So let's look at this problem. Suppose customers in a hardware store are willing to buy N of cost P boxes of nails. So NP is cost of nails. All right, where N is quantity. At the cost of nails. I might better write it correctly. Notice that we have the price is $1 up to $4. And you're making a choice of how much you want to charge to optimize your purchase power or demand. This is a demand. A demand analysis is what will the public bear in cost of purchasing these nails. So let's look at A. Find the average rate of change. All right. For demand change, for the change in price from 2 to 4. So here our A is 2 and our max is $4. All right. How much will the demand be? How many people will buy this product? All right. So let's look at it. Let's say, all right, N of P equals 80 minus that 5P squared. All right. So we want to use our calculator. So we're going to enter the function. And we're using X for P. So we're going to go to the Y equals, clear out any clear key, any graphs that are in there. All right. And then we're going to enter. And to enter this guy, we're using Y1. And in Y1, we're going to enter the following. 80, a number, minus 5, and then we're going to do the X key, which is second row, second key, and then we're going to do the X squared key, which is down on the valley. Okay. So now we're going to graph it. Notice that our domain is $1 to $4. We can change the window if you like, but we're going to just do zoom, choose 6, standard, and that means a 10 by 10. Okay, and then we're going to calculate. Once we get, let's do that part first. So I'm going to hit my calculator. I'm going to type Y equals, I'm going to clear all of my functions. I'm going to enter 80 minus 5x, second row, second key. And then I'm going to do the X squared key, which is 1, 2, 3, 4, fifth row down. All right. I'm going to hit the zoom 6 because I don't know what I have. And there it is, my demand curve. Now, we could go to the top. It would have to be like an 80. But we'll see what we can do with this. All right. So now we want to calculate Y values or output. Or the number of dollars, the cost, for the cost, right? So we want to do F of 2, and we want to do F of 3. Okay, the two prices. Okay, all right. So here we go. I'm going to do, now, I better write the conditions. To find this, we're going to do second trace. That's under the graphing notations, and this is for calc. And we're going to choose number 1 value by enter, the enter key. All right, so here we go. So we're going to get our calculator, second trace, and value is 1, so I hit enter. Now I'm going to put the values 2, and I get 60. Then I'm going to enter 3, and I get 35. So I have the cost of what they want us to get. And now I'm going to take the average, okay? Notice that at $2, we have 60 boxes that they'll purchase. At $3, the demand is 35. But we want the average rate of change in the cost to see if it's marketable. So now we're doing the math. We're still on A. Now we got all of that information, and we want our average. And it is just the limit. We don't need the limit. It's f of b minus f of a over b minus a. For us, it is f of, and our first number, a big number was 3, minus f of 2 divided by 3 minus 2, which is 1. So now let's put up what the values we have. We got, now look again, 60 for 2 and 35. 35 boxes, or cost, minus the 60 over 3 minus 1. And that gives us a negative value of 25. Well, what does that mean? You ask. Well, that's a good point. It means that the demand or costs change from $2 is a reduction of 25 boxes. All right. So, loss of money, because it's money. All right. So now the B part. I know it's confusing a little bit, but I like the problem, so I wanted to do it. The B says find and interpret instantaneous change. So this guy is the limit as h approaches 0 of f of, and I'm using what they wrote to the function, a plus h minus f of a all over h. All right. So in this case, a represents the function. And in replacement of that p, we will put the x, or p plus h. So here we go. Our function is all right. Now we're just talking math here. So let's get started on this math. So our first one Now, you remember I do it for a living. Use FOIL, first, outer, inner, last, if you need to. I'm going to have an 80 minus 5, parenthesis, the square of the first term, plus twice their inner product, plus square of the last. And I'm going to put the distributive property here, 80 plus the 5p squared, all over our h. Now I'm going to simplify. So this will give me 80 minus 5p squared minus 10 pHs minus 5 pH, I'm sorry, no, not a p, just h, sorry, h squared minus 80 plus the 5p squared, all divided by h. Now remember, in the next course, the course that we're doing, we're going to eliminate this and do a short form, so you can have something to look forward to. I have additive inverses that zero out. Okay, notice that everything left has an h in it, so we're going to put the GCFX of h on the next line. Now, I'm going to go sideways. I'm going to factor out that h. Over h, because we can't have 0 in the denominator, so the h's always cancel out. If the h's do not cancel out, then you have a problem, Houston. Got to go back and look at the math. So it is a negative 10p minus 5h. Now we're going to take the limit. Therefore, the limit is a negative 10p. All right. So there we have what our function is to find the limit. And they wanted us to find the limit for the price of 3. So now we're going to find the limit as p approaches 3 of the negative 10p. Well, naturally, we're going to get negative $30. So the average in between, if we wanted to go in between the 2 and the 3, would be a less $30 per sales. So that's what that is. All right. So now we have this question here. Find the instantaneous rate. Oh, I'm sorry. This was at 2. I did the 3. Sorry about that. This was at the $2. So we want the, let me put this down. This should have been for 2. Sorry. And that makes it a negative 20 from that average. And now remember, when we did the first one, the secant one, the direct line, I got negative 25. And this came out as negative 20 at 2. So now we want the limit of demand as P approaches 3, because that's our C. And that's negative $30. At that one point, any point right there, that one singular point, it's a drop of 30. And we averaged a negative 25. All right, so what does the D say? As the price increases from 2 to 3, how is the demand changing? Okay, for D, it is decreasing demand. All right, so that's what we're going to state on that problem. Very good, class. All right, so now we're looking at adding a word to derivative. We know that average rate of change is slope. And then we know instantaneous rate of change, slope at a specific point. As we experienced with the limit. If we did the secant, it was larger, it was averaged at a negative $25. And if we did instantaneous rate, it was 20 at $2 loss of revenue, and 30 if we did the instantaneous rate of change. So now we're calling this a derivative. Can't spell. Sorry about that. All right. So we're saying now a derivative is the function that calculates the change at a specific point. And again, it's the difference quotient. Now, the equation of a tangent line. Now, let's talk about a tangent line. So if I have a parabola, a tangent line at this point would be the line that just touches it at one point. At some xy. All right, so a tangent can occur anywhere at any point in this. I drew this kind of yuck, but it's that point. And we could even have this one here. Oops, boy, can I not draw. Okay, so we have all of these points that we can make a tangent from by selecting that item. So a tangent point is a line, y equals mx plus b, that touches the function at one point. One point. And so we know it as, now they write it as y equals y sub 1, y minus y sub 1 equals m times x minus x sub 1. So that's what this is right here. Because we know that the point x1 and f of x1 is x and y. So that's what we're doing. I'm going to make an equation of the tangent line. So here we go. I know it's a lot of review, but I think we're taking it as calmly as we can, and I've been as explicit as possible. For each function, find A is the equation of a secant line. That means we start with 2 points. secant t at the x at the given value. So we're going to do this one first. So we have the function f of x equals x squared plus 2x. It's a parabola for x equals 3 and x equals 5. So I need f of 3 and f of 5. And we know to do it in the calculator. So we're going to do our calculator. I'm not going to write the steps because we've discussed them. All right, so here I go. I'm going to come over here. All right, so I'm going to go to y equals, I'm going to clear it. I'm going to enter second row, second key, and x squared at 5 minus the 2x. All right, I'm at zoom 6, so I can just hit graph. There it is, it's a parabola. All right, so we do second trace for calc value, and we want 3, and we get 3. Well, I did something wrong. Let me look. Oh, I put a minus instead of a plus. Nobody caught me. All right, sorry about that. So let's do it again. Second calc, garbage in, garbage out. That's the rule. And I did garbage. So I did 3. Now that makes sense. All right, because that's 9 plus 6. All right, I mean, we can do it in our head, but why do it if we made you buy this? And then we get 35. All right, now we're going to use our average rate of change. And that means f of 5 minus f of 3 all over 5 minus 3. Okay, so we know this guy here is 35 minus the 15 over 2. All right, so that gives me 20 over 2. My slope is 10. Okay, is everybody comfortable with that? 10. 35 was here, minus the 15, and that is definitely 20. And 5 minus 3 is 2, it's 10. All right, so they want the equation. So now we're doing the equation. So we're having, it says y minus that y's of 1 equals m parenthesis x minus the x of 1. All right, so here we go. And we have to choose a point. Doesn't matter. Well, let's choose this one. It'll come out the same either way. Y minus the 15 equals 10 parenthesis x minus the 3. All right. So that's y minus the 15 equals distributive property 10x minus 30. I'm going to add 15. So this is my equation of the secant line. So let's look at that in our calculator. We're going to enter that equation on line 2. Y equals 10x minus 15. If I did the math right? Yeah, I did. Okay, now I'm going to graph it. All right, well, it doesn't look good because I can only see one crossing, and it is at 5, I think. Second calc value at 5. Now it says 35, which we got, and then if I down arrow the red one, it's also 35. So the line is drawn from the average rate to that point. It is good. That is good. All right. So now we're going to do the B. And the B wants the equation of the tangent line at x has the first value. The first value is 3. f of 3 equals 15. All right, so now we're going to take the difference quotient to find the instantaneous rate of change. All right, so let's look at that. So it is the limit as h approaches 0 of the function x plus h squared plus 2 times x plus h minus x squared plus 2x all over h. All right, we're going to do the limit as h approaches 0, and I'm going to do the math. Square the first term plus twice their inner product plus square the last term. And that takes care of that one. Plus, this is distributive property, 2x plus 2h. Then I have this guy right here. And I'm going to have minus x squared minus 2x all over h. Okay, so we're going to cross out the additive inverses. And I'm left with all h's. So now I'm good. Sorry, that should be an h. Right. Cancel out my h's. And we're going to take the limit because h is 0. So this is the function for slope at any point. And they want the first one, so that was 3. And that is 8. The slope is 8. Now we notice the change between the tan slope of the secant line and the slope of the slope of the instantaneous rate of change, because we're talking about 3. So and we saw the difference already. So now we want the tangent slope. So our slope is 8. Our x value is 3. Our output for x was a positive 15. Right. So I'm going to do some math. Sorry. I'm going to add 15. I'll do that on the calculator just so I'll make sure. Second quit, by the way, gets us on the home screen. So I had a, what did I have there? Let me move it over here. Negative 24 plus, because I'm going to add the 15, negative 9. Making sure. I'm going to come back to my graph. And on the third line, I'm going to enter 8x minus 9. There you have it, right at the same point as before, but closer with only one point to show. All right, so there you have it, guys. Now you can do the exercise and complete it and submit. Thank you for listening.